Good day. I am Oh Pei Ching, a chemical engineering lecturer from University Technology Petronas. It is my pleasure to share with you my experience on implementation of cooperative learning for process plant design via integrated design project in virtual learning environment. In the course of a chemical engineer's undergraduate degree, they are expected to design complex engineering solutions for chemical processes with appropriate considerations for safety, health, the society, as well as the environment. Process plant design deals with the interdisciplinary integration of fundamental and specialized chemical engineering core subjects such as thermodynamics, separation processes, reaction engineering, as well as process safety and loss prevention. Traditionally, this subject is taught based on the figure of the lecturer, with students acting as passive agents in a face-to-face classroom environment. Nevertheless, in recent years, it has been established that successful learning should involve students in deep learning. In terms of deep approach, in comparison with surface and strategic approach, the distinction is that it requires depth of involvement, commitment, interaction, as well as applications. For surface approach, the students tend to memorize and reproduce with the intention to complete a task. For strategic approach, they are often geared toward the preference of the educator with the intention to obtain high grades. Whereas our intention is for students to engage in deep approach where their intention is to understand. This involves active engagement with the subject matter. Now, engaging students in deep learning has become even more challenging recently due to the abrupt migration of teaching and learning activities to the virtual environment. Hence, this work aims to incorporate cooperative learning via integrated design project in a virtual learning environment. This IDP is the type of project-based learning activity implemented on a process plant design course within the bachelor's degree of the Department of Chemical Engineering at University Technology Petronas. Project-based learning requires critical thinking, problem-solving, collaboration, as well as various forms of communications. For this teaching practice, the educator will need to design and plan the project, as well as engage and coach the students, be able to assess the students' learning activity, have scaffolding for the students' learning, manage the activities seamlessly, as well as to build the deep learning culture and be aligned to the teaching and learning standards as well as technical standards. For cooperative learning, we need to look at several elements including positive interdependence, individual and group accountability towards the completion of the project, interpersonal skills, promotive interaction, as well as group processing. In order for this integrated design project to be successfully conducted, students should be able to access online learning resources as well as have good internet connectivity to enable self-directed learning. For the IDP implementation, the students were divided into small heterogeneous groups of 4 or 5 to carry out the project tasks. The groups consisted of students with different ethnic background, academic prowess, as well as gender in order to achieve the relevant course learning outcomes. So these activities were postulated over 12 weeks of the semester. Firstly, a design question is postulated, followed by brainstorming activity using Mentimeter. Problem solving in groups and scaffolding sessions were facilitated and conducted via Microsoft Teams breakout rooms. Subsequently, the process flow diagram, PFD, layout of the process plant as well as the mass and energy balances of the process routes are generated using Aspen HiSys software via virtual machines from the university. The reports, such as the interim and final reports, are submitted through the university's Moodle ULearn online platform. Peer evaluation as well as the reflection activities are conducted via Microsoft forms anonymous questionnaire. So this information is crucial in order for us to gauge the students' understanding as well as to improve course delivery in enhancing the students' learning experience. This slide shows an example of the postulated design question. For process plant design, integrated design project constitutes 20% of the total marks. The design question here postulated for the students is for them to design a plant for the production of phenol from cumin. That design needs to meet the design requirements stipulated for conceptual process design, as well as it needs to be cost-saving, economically friendly, and safety should also be a topmost priority, as well as giving priority to the environmental concerns. During the beginning of the project, brainstorming was conducted via Mentimeter in order to generate ideas within a short duration without judgment. Problem solving in groups was also employed to assist the students to move forward more efficiently in their learning process. So in this project, Aspen HiSys software was used to calculate the required thermodynamic properties for simulating the mass and energy balances. This shows an example of the process flowsheet using Aspen HiSys. Cooperative learning was conducted, and this was carried out via Microsoft Teams, breakout rooms, facilitated by graduate assistants as well as the educators. The students also are required to fill in the peer evaluation forms in order to ensure individual and group accountability, and this is conducted periodically throughout the learning duration. From the results obtained, the majority of the students were satisfied with the contribution of their respective team members towards the completion of the project. From the summative assessment conducted, the overall academic results were evaluated, and it was found that the students managed to obtain grades between A and C without any failure. Through the integrated design project implementation, the students managed to achieve the intended course learning outcomes for this course. Furthermore, the majority of the students were satisfied with their learning experience and found that working in groups enhanced their learning. Besides that, project-based learning increased the students' learning motivation, and this may contribute towards the improved academic achievement. In contrast, approximately 1% of the students were dissatisfied, probably due to they need to spend more time for the completion of the project. In summary, from this study, it was found that integrated design project is effective in engaging distance learning for students, wherein they maintained high level of motivation throughout the course. This has also translated to the overall improved students' academic performance for process plant design course. This is a good learning method which engages the students and keep them motivated. However, the limitation of this study is that more data is required to assess the direct correlation between student motivation and academic achievement. Implementation of project-based learning has blessed me with several recognitions in previous years for traditional classroom environment. I would also like to acknowledge the support from my university as well as my colleagues for formulating the design problem statement and group formation. I also wish to extend my appreciation to the graduate assistants who has helped in facilitating the completion of these project activities. This is the list of references used to prepare the presentation pack. With this, thank you very much for your kind attention.